The panel cutters assembly is a custom assembly to work with the Pushing Points MOP Booleans kit for Moto. It comes with 3 new operations and another layer of sub, union, and intersect operations, and we'll get to why that is later. So first we'll start with the panel operation, and what that does is it cuts out a space in between our Boolean mesh and our base mesh. The next operation is the union panel, which will do a union, but leaves a space in between our union and our base mesh. If you look closely, you can see it. This is good for doing stuff like buttons, where you wouldn't want to have a straight up union because then the rounded edge shader would get confused. The last operation is the wide union panel, which does the same thing, except it leaves a little space in between our Boolean mesh and our base mesh. One thing to note is that your panel meshes do not actually need to be closed meshes in order for them to work. So if we were to take this cube and make it a panel, we can actually delete these 2 faces because they aren't connected to our actual base mesh. So if we hit delete, nothing changes here. Of course, we can keep modifying our mesh if we want, so let's select these faces and do a bevel, and you'll see that it affects our panel. This assembly is also set up to work with materials, so if we were to set our base mesh to be a red material, like so, and we wanted our panel to make everything inside of it green, we can do that. So let's select our panel mesh, give it a new material, we'll make this green, and you'll see that nothing happens. Well, something does happen. You'll see that where the panel cut away from is now green, but that's not what we want at all. So if we want to do what I talked about earlier, we would have to select our build mesh and change a setting in it. But you'll see that we don't actually have our build mesh selected because it can be hard to select our base or our build mesh depending on what Moto feels like doing. So this assembly also makes it so that you can press up or down when you have your build or base mesh selected, and it will toggle in between them. Anyways, in our build mesh, the first thing we have to do is go to our user channels and change the panel gap material. That's the material that applies to the side of panels that is connected to our base. So that would be our red material, which is whir, and you'll see that the inside is now red, and the inside of this one is now green. Then we have to tell it what the different panel materials are, and it is set up to have 5 materials initially, but it's not very hard to add more. So if we were to set this to our green material, you'll see that everything inside of our panel now turns green. So let's say we want to make our cylinder blue. We'll select it, give it a new material, I'll call it EEE, and we will make it blue, and hit OK. And you'll see that the sides of our cube that is connected to our cylinder aren't blue, they're still red. So once again, we just have to add that material to our build mesh in here. So panel material 2 will now be EEE, and you'll see that our blue is now applied to the right faces. If you're just working with the union panel, you really don't have to worry about the materials that much. So if we were to give this a new material, I'll call it RR, and let's make it, I don't know, green, dark green. You'll see that everything's fine because, well, you really don't have to worry about it if you're just using the union panel. Now these operations are stacked in alternating order. So for example, you can see that this cube is cutting into our cylinder here, which may not be what you want. So we can change this from being a union panel to an alt union panel, and you'll see that our cylinder is now cutting away from this cube instead. Also keep in mind that these operations happen in the middle of our stack. So if we were to do a normal subtract to this cube, you'll see that nothing happens. It's not cutting into it because this subtract happens before this cube union happens. The same applies if you were to do an alt subtract, because these new operations happen after the alt layer of our drivers. So if you want this cube to subtract from this cube, we have to do a alt 2 sub or above. And this is where we get into why we have an additional layer. You'll see right here is that when this cube cuts into this cube, the color doesn't change where it cut. Anything that is in the Alt 2 layer won't affect the colors of our panel cutters. So if we want this to actually affect the colors, we have to do a Alt 4 or above. So if we do an Alt 4, you'll see that that space is now white. But if we wanted to put another cutter in here that overlaps with our cutter, you'll see that bad things start happening because you shouldn't have overlapping geometry in the same layer, which is why we have the Alt sub 4 layer now. So we can do that. Another thing to keep in mind is that our panel operation happens before any of this stuff. So if we were to move this cylinder over our panel, you'll see that our panel does not cut into our cylinder. But if we were to bring back some of the faces on our panel cutter here and change it from a normal panel to an alt panel, you'll see that it now cuts into our cylinder. Now, working with these panels can be pretty expensive. So what I've done is I've made it so you can just toggle them on and off depending on if you want them there or not. Off, on, off, on. You'll see that the colors will stay on all of our new operations except for the panel, because the panel isn't cutting into anything, so it's kind of hard to put the colors there. Usually what I'll do is I'll turn off the panels to make my low res mesh, and then I'll bring the panels back on to make my high res mesh. And you can change this setting in our user channels under enable panels. You can also change the panel's width, so let's change our panel gap width to something bigger, to say 10 millimeters. But that's kind of ugly, so let's bring it back to 2 millimeters. And you can also change the union panel width, which is this area right here, the space in between our union and our panel. So if we bring this up to, say, 20 millimeters, you'll see that that area is now much wider. Now this assembly doesn't overwrite any of your previous hotkeys, and if you were to go to your kits and try to change it in your MOP Booleans hotkey setup thing, none of these will appear because it's not officially part of the MOP Booleans kit. So you have to set up your hotkeys yourself, but I'll show you how to do that really quick. If you want to make your pie menu, this thing right here, what you'll want to do is go to System, Form Editor, and scroll down until you see pie menus. Then you want to scroll down to the bottom where it says New Form and double click that. And when you do, it will ask you for a name, and I chose the name MOP Panel Cutters. Click on your new pie menu, go down to the style, and change it to pie menu. I think initially it starts off at default, which is like a list of buttons and not a pie menu. So click pie menu, and then you'll go to new control and click that once and hit add command. When you do, a new pop-up will appear asking you for that command, and I'll just leave a list of the new commands somewhere over here. And basically you'll just go through each of the commands and add them to your list of commands in your MOP panel cutters. And if you want to preview what it looks like, you can just hit preview form and you'll see it pop up over here. Now if you want to set up hotkeys, which I suggest you do because hotkeys are much faster, you go to System, Input Editor, and then find whatever combination of modifiers you want. So if you want Control and Shift, you would hit Control, hold on to Control on your keyboard, and click Shift, and that'll bring up all your hotkeys for Control and Shift at the same time. And find whatever key you want to use. So if it's not showing up, you might have to click the Show Unmapped Keys. When you do that, it'll show everything that isn't mapped. Anyways, when you find the key that you want, you just double click it, it'll ask you for a new command. That command is exactly the same as it was for your pie menu commands. So I'll leave the list over here again in case you don't want to scroll back to when I was showing you the pie menu commands. And as a final note, I'll show you how to actually install this assembly. So you would just take your assembly, rename it to pp_mop_booleans, find your assemblies folder for your MOP Booleans. I'm using Modo Indie, so it's in my Steam, Steam Apps, Common, Modo Indie 10, Kit, MOP Booleans, Assemblies. And then just paste it in here. But before you do that, I would copy the original MOP Booleans LXP and rename it to version 2 or something like that in case you want to go back to the original MOP Booleans. Anyways, that's it for this video. I hope that this assembly helps you out and that you enjoy using it. Bye!